All right, so before we get in there, just want to make sure we do some, let me see what stuff. All right, so MyMathLab is the main thing you guys can use. Hopefully you got my emails as far as the details of MyMathLab. We're going to talk about those in a second. And then also the importance of MyMathLab. Of course, you cannot pass the class without MyMathLab. And that same thing goes for Connect Math. Whether you're using MyMathLab or Connect Math, it's the same principles. You cannot pass the class without getting access to either one of those. Also, I mentioned that you don't have to purchase a hard copy of the textbook because in either one of the computer components that we're using, like I said, whether it's MyMathLab or Connect Math, you will get an e-copy of the textbook, so you will have access to the text. That's why it's not mandatory that you buy a hard copy. Everything will be solidified through MyMathLab or through whatever computer component we're using. We'll meet regularly through class. I will record each lecture, and then I will also create a link through YouTube in which you'll be able to review each one of the lectures. So, like I said, everybody's expected to come to class, but if by some chance you miss class, you will be able to go and look at the reviews. Also, with that means what I will most definitely be doing is taking attendance off of your participation in MyMathLab. So I will be looking at attendance, as far as when we have our Zoom meetings, but on MyMathLab is where that will solidify your attendance. So if you miss a class on Zoom, I won't hold it against you, but I will be looking at MyMathLab and say, okay, well, this person has been doing work. So you most definitely want to get in there, a couple times throughout the week, even if it's no more, just going to assignment, hitting save, and then coming on out just to get you a time stamp and a date stamp on some type of activity. So you do want to be active in MyMathLab. All of announcements or all the emails that I send to you guys will be archived in your Canvas announcements. So I'll show you where that is as well. So any email that I send, I will actually be posting it twice. I will shoot it to you in the email, and I also post it in your Canvas announcements. So make sure you guys can see this. So of course, Canvas is right here. And so announcements right here. And these are the 4 emails that I sent. So once again, any email that I sent to you guys, I will put in Canvas announcements. So if you feel like you haven't heard from me in a while, or haven't seen something from me in a while, you can always go to the Canvas announcements and see if anything else was sent. All right, pretty good on that. Okay, so here, going to MyMathLab, www.mymathlab.com. So that website, and some of you have already logged on and registered, and that's cool. I appreciate that. You hit register as a student. Register now. Here you would use that course ID that I sent you. It was Tucker 828. And so here, if you already have an account with Pearson, you can go ahead and put the information here. If not, create one and put in your information. So once you do that, it'll give you 3 options. You can either put in a access code, or course ID, access code. Sorry about that. Put in an access code for that you've already purchased through Barnes & Noble. You can purchase access, in which you would purchase access through them. They wouldn't give you access code because they would just give you access. Or you can click the 14-day free pass, which will be somewhere down here on the bottom. It's going to be very small like this, just a little link that will give you access to 14 days free, full access. So if you don't pay for it before the 14 days is up, what'll happen is it will lock you out. You will not lose your progress. I will still be able to see your progress. You just wouldn't be able to see it. And then once you pay, it'll let you pick up where you left off. All right. Any questions on that? Any
I
questions?
paid for the 12-week one. Is that good?
12 week. Well, I didn't even know they must be presenting new options. So just making sure that I got it. I didn't even know they did a 12-week one. So is the 12-week one supposed to be cheaper than?
Yeah, it's 12, 18, and like 24.
Okay.
Yeah, so
Okay.
the 12-week one is, I believe it's $50.
Okay. Okay. Cool. I didn't know they were doing that now. That's good. Yeah, that should be fine because this is a 10-week course. Yeah. Now, just heads up. If you do that during the semester, just make sure that whether you make sure that you either signed up for 8 week or a 10 week session, dynamic session, because normally the semester is 16 weeks. So just throwing that out there for a regular semester. But that 12-week option should be good for us. Yep. All right, cool, cool. Anything else before we go any further? Everybody good?
So we can purchase the access code directly from Mymathlab website. Is that
Yes.
what you said?
Mm-hmm. Mm-hmm. And so the
Okay.
only thing about it is if you use financial aid, though, you wouldn't be able to do it through financial aid. Yeah.
Okay. And you said you sent us the okay, so Tucker 82856, that's what we will put in for now.
Mm-hmm. Mm-hmm. So that's
Okay.
what gives you access to the shell. So basically, you need two codes. If you purchase outside of Mymathlab, outside of Pearson, you would need the course ID, which is that Tucker 82856, and then you would need that access code. Let's say if you got it from Barnes and Noble, they will give you like a 16-digit access code to type in.
Okay.
Mhm. And then once again, if you purchase it through Pearson itself, though, they wouldn't give you access code. They would just give you access.
Okay, thank you.
Mm-hmm. Yep. Yep. I think. Okay, good. All right. So let's go in here and see what our assignments look like. Okay. So you guys would, I was looking about some got different shells that set up differently. You guys would click on assignments, and here will be all your assignments and your tests. All right. So you guys will be, you can take your homework or do your homework at your leisure. Um, Now the due date is 8/8. You see that right there, which means it's our last day of class. So what that means for us is that you guys will have the luxury of going in and out of your assignments, doing your work. But of course, you cannot wait until August 1st to start doing work because you have a list of assignments to do. But like I said, I just put the date out there like that to give you freedom to move in and out of your assignments. But as we progress throughout the course, you are expected to be progressing throughout your homework as well. So that 8/8 date, that's not saying that everything's due by then because you'll have a test after these 5 homework assignments. There's a test on that. Then after the 6 assignments in chapter 10, there's a test on that. And so you don't want to get behind doing your work because you are expected to complete all of your work and all of your assignments. All right.
So how many do you suggest we do a week so we can stay on track?
Just keep up with me with the lectures.
Okay.
Yep. So it just depends on how we're going through. Now, if you want to move ahead, you're most definitely welcome. But I would say you can always pace yourself according to where we are with the lectures. So if I only do uh let's say one class, I only for some reason I only do 3/3. I can't see that happening because we have 2 hours. But let's say for some reason I only do 3/3, then you just know that 3/3 is really the only thing you're held responsible for, you know, for that day, or up to that point. Yeah.
Okay, cool.
Yep. You will be taking your test until we get done with the material. Depends on if we have if we have extra time on the back end. You will be taking your test through Mr. Davis, and I should send you guys an email. You don't need it now, of course, unless you're ready to take a test today. But Mr. Davis and they call it the tutors? Yeah, the tutoring center. It's not the testing center. The testing center is a whole nother center at TCC. But Mr. Davis and the testing center. And so what that does is it allows you to take your test at any point in time. You would just contact Mr. Davis, and either him or somebody from his team will contact you back with the details on how you would take your test. So you're not going to, go and meet, like I mentioned, like I sent the email before describing the class. This is all virtual. Now, and I'll come back to that. I won't say now. I'll come back to that. But this is all virtual, so we're not going to meet face to face at all this session. So any testing we do, it will be through Zoom, in which they will give you details on how they expect you to do so. I will do testing as well, but it will not be for the early part of the session because I want us to get through these sections so you will be able to start testing and stuff like that. So any questions on that? Like I said, I'll shoot you an email on that information shortly. Everybody good? Everybody good? Okay.
So the testing is not done on the MyLab math?
Yes. So your test here, like right here, is that test right there. So what's going to happen is you would log on to Zoom through Mr. Davis, and he will have a password. Like if you were to click on this now, let me go back to the assignments. Like if you were to click on a test right now, see my stuff is set up a little different than you guys. Let me see if they let me do it this way. Oh, nope, that's not the way to do it. Go back. All right, so click on the test and see how it asks for a password. So that's what you guys will get when you click on the test. It'll ask you for a password. So I don't give you that password until you're ready to be proctored. So whether it's you taking the test through me or taking the test through Mr. Davis or somebody from his team, when you go in, you'll click on that. Then they will give you the password. Then you type it, and then you will stay on Zoom while you take the test.
Okay, got it. Thank you.
Yep, not a problem. All right, anybody else? Anybody else before we good? Okay. So I did want to emphasize the difference between, because a lot of people have a little bit of trepidation about learning online or learning online. So we consider this learning more so learning virtually versus, I can't even think of the other name, but it's still learning online. I can't think of the other name that I'm looking for. But when you learn virtually, it's not necessarily like that you're on an island, by yourself. We meet every class period, call it synchronously. We can have office hours, and if you need office hours, shoot me an email so we can line up our schedules. Through this whole situation, it's always been easiest to see, okay, what your schedule look like, what does my schedule look like, and then find a time that both fits, if it's both of us, versus me having specific office hours that you can't meet, and we probably have to have that conversation anyway. So if ever you need extra help outside of class, always feel free to shoot me an email and we can set up that time. Excuse me. Also, every day is going to be an opportunity for questions. We have 2 hour block. So I don't plan on talking, specifically for 2 hours. So there will be time wherein I'm done lecturing and you will be able to answer questions. Ask your questions, and hopefully I'll be able to answer them. But learning virtually, like I said, you're not on an island. You're not just getting videos, and you never see me or never, contact me or never hear me talk to you. Like I said, every day we will be meeting. Every class day we will be meeting, and it's the same experience that you will have in the actual classroom, unless there's a technological glitch. So what I mean by that is that this is how we would be having our lectures. I'll be talking, writing. You know, you will see me write and talk and hear, you know, all that stuff like that. So, yeah, so the same experience that you will have in the classroom is the experience that you will have here. I'll be writing on the board while I talk. And the only difference is that it's being recorded and you can go back and review it, which is a benefit to us. But yeah, so just trying to taper any type of trepidation towards learning online. I can't speak for everybody else, but I just know my class, we pretty much flow in the same way we would as if we were face to face. All right, you can unmute, interrupt if you have any questions, ask me to re-explain. Uh, yeah, it's the same flow. It's the same flow that we would have if we were face to face. All right. Any questions on that? All right. I think that is it as far as introduction. Your syllabus will be in, you just need to look at the syllabus. Your syllabus is in Mymathlab. Go back here. So your syllabus is right here. And that's the syllabus from last semester, but it's all the same information. I'll update it shortly, but yeah, if anybody wanted to see it. Anything else? Anything else? Oh, also what I will shoot you guys is the links, or all the links from last semester, just in case somebody wanted to move ahead. All the videos from last semester. Yep. So I'll do that shortly as well. All right. So anything else? Anybody else before we get started? All right. So most of my notes I've already written, like I said, from last semester and stuff. So a lot of times I'll be erasing and rewriting and stuff like that. Let me check one more thing before we get rolling. Mhm. Okay, so let's get going today. We'll talk about a couple sections and then I'll call it a day. Like I said, we have 2 hours. I don't plan on covering everything or talking about all the math in the world for 2 hours, but we do want to get some stuff in there. All right, so 3.3, solving linear equations. So an equation is a statement that says that two algebraic expressions are equal. So an example of that is x plus 5 is equal to 8. Okay. Oh, also, if I, especially since I already have a lot of this stuff written up already, if I scroll up too fast, all you have to do is say, Mr. Tuck, can you scroll back down real quick or something like that? Or if you just want to take a picture of it, whatever you want to do, let me know. But I won't know unless you say something. I won't know unless you let me know. All right. So solution, which is what we will be looking for, will be values that will make an equation true. So in this case, we're looking at x equal to 3 would be our solution, because 3 plus 5 is 8. You can always plug that solution back into your equation, see if you get that true statement. 3 plus 5 is equal to 8. And so you're supposed to be answering this question right here. When is x plus 5 equal to 8? And that's when x is equal to 3. All right. So of course, we will not be guessing at our solutions. We will not be just throwing stuff in there to see what works and what doesn't work. We will be able to solve by certain practices. And what we will be using is what I call opposite operations. They are operations that will undo what the other one does. So addition and subtraction are opposite operations, or opposite of each other. Multiplication and division are opposite of each other. They undo what the other one does. All right, so what that means is that when we go to solve for our variable, we want to get our variable by itself. You know, we go back to x equal to 3. We have x on one side by itself equal to our solution. So that's what we want. We want our variable to be on one side by itself. So we need to undo what's being done to our variable. If I have x plus 5 is equal to 8, I want to undo the addition of 5. So what I will do is subtract 5. Remember, we're talking about opposite operation right here. So addition is being done to the x. So I'm going to subtract 5. Also, our equation is split up into two sides and it's split up by our equal sign. So we got the left side of our equal sign, right side of our equal sign. And the reason why that is important is because whatever you do to the left side of your equal sign, you have to do to the right side of your equal sign in order to keep your equivalency. So if I subtract 5 on the left side, I also need to subtract 5 on the right side. 5's cancel on the left. 8 minus 5 on the right is 3, and that's how I get my solution. X is equal to 3. And that is the foundation of solving equations. Your goal is to get your variable by itself, and you will be doing so by performing the opposite operation to each side of your equation. All right. So we'll do a few one-step equations just to make sure we're good. If I have y minus 10 equal to 15, I need to add 10 to both sides in order to solve for y. 10's cancel. Y is equal to 25. Next one, 5a equal to 13. That's 5 times a. So I'm going to divide both sides by 5. 5's cancel, and that gives me, or leaves me with 13 over 5. So 13 over 5, notice I left it as 13 over 5, didn't convert to a decimal, and or neither did I convert to a mixed number. You do not have to at this point. They assume that you're pros at doing that. Unless it says specifically in your directions to do that, you do not have to. Now, they do expect you to reduce. So in other words, if I have 4 over 6, and you can't reduce it because, 4 is 2 times 2, 6 is 2 times 3. And then, so your final answer would be 2/3. They do expect you to do that type of process. So if this 13 over 5 could have been reduced, then they would have expected you to do that, but you do not have to break it down to 2 3/5. Okay, just making sure we're clear on what you have to do, what you do not have to do. Everybody good? All right. Then one more one-step problem. We have x over 9 equal to 11. So you multiply both sides by 9 so that they'll cancel out. And then 11 times 9 is 99. All right, any questions before we add a little more to it?
So for the equation on top, you had a equals 13 over 5. Then you said we need to, did you say reduce it to 2 3/5?
No, I was saying this is an example of reducing.
Okay.
Right here is an example of reducing. I say you do not have to do this.
So the answer is 13 over 5.
Right.
Okay.
Yep. I just want to make sure people don't look at this and say, I got to go further. If it cannot reduce like this, in other words, you know, like I said, there's a 2 in common with both or 3 in common with both top and bottom. If you don't have something like that, then you can leave it as 13 over 5. Hopefully that's clear. Should be good. Any other questions before we move on? All right, so let me read some of this stuff. All right, so we have this original problem of 2x plus 1 equal to 17. All right, so we have multiple operations here that's being applied to this x. We have it's 2 times x plus 1. Now you could move the 2 first. You have options here. You can move the 2 first, or you can move the 1 first. But if you do move that 2, you're going to have to divide everything by 2. And that will not produce the easiest way to get your answer. So the most efficient way is to move that 1. So we will subtract 1 from both sides. All right. And that'll leave us with 2x equals 16. And now I have 2x equals 16, so I'll divide both sides by 2. And my solution is x equals 8. All right. Any questions on that? All right. Any problems? Everybody good? All right, let me erase stuff, y'all. All right, so our original equation, 3a minus 6 equal to a plus 4. So notice we have a on both sides of our equation. Our goal is to get all of our terms with a on one side, all of our terms without a to the other side. So the way we'll do that is that we can just move our terms to the left, decide which one you want to move. We have 4 different terms here. It doesn't matter which one you decide to move first. If you stay consistent in what you're doing mathematically, you'll still get the same answer. Also, keep in mind that there's a 1. That's what I was emphasizing here. There's a 1 in front of this a. It's always assumed that its variable is alone. There's nothing in front of the variable, that there is a 1 there. So if I want to move the a to the left side and subtract a from both sides, so a minus a will cancel on the right, leaving us with just 4. Then on the left, 3a minus a, it would be 2a. So that's 2a minus 6 equals 4. All right. Trying to get this, I have department head contacting me while we're talking about the Mymathlab situation. So if I can get clarity before you guys leave, then that'd be great. All right, so we got 2a minus 6 equal to 4. And so now we want to get the 6 to the other side. So we'll add 6 to both sides. 6 cancels. That leaves us with 2a equal to 10. Divide by 2. 2's cancel, and a is equal to 5. Any questions? All right. Everybody good? Scroll up. All right. Maybe some of this. All right. So we have here now 17 minus 7x plus 3 equal to negative 33x plus 21 minus 3x. All right. So we have different sides of our equation, but we have common terms on both sides of our equation. So what I would do is simplify as much as possible on the left side, simplify as much as possible on the right side, before I start moving things across the equal sign. And so what I mean by that is that we see over here, 17 and the 3 can be added together to give us 20. And we're not using opposite operations because they're both on the same side of the equation. We're just adding them together. And then the same thing over here, we have negative 3x and negative 3x. Add those together, that gives us a negative 6x. All right. Any problems? Now, once again, we haven't used opposite operations yet. You only use that when you move across your equal sign. In other words, if I go to take this, still have my eraser up. If I want to take this 6 over here, then I will have to use opposite operations. But if I'm just adding or subtracting on the same side of the equations, I would just use whatever signs are given to me. All right. So now, once again, I have my variable on both sides of our equation. Your goal is to get your variable terms or your terms with variables on one side, terms without variables to the other side. Doesn't matter which one you decide to do. Just make sure you are consistent in what you're doing and the process you're flowing with. So I added 6x to both sides of my equation. Once again, if you wanted to take the 7x to the other side, you could have done that. Either way, at some point, we'll come up with the same answer. So that'll give us 20 minus x equal to 21. Then I will subtract 20 from both sides. And make sure that minus sign is not lost. That's why I have that arrow there. So that's still negative x. And negative x is equal to 1. Then to finish it off, take the negative to the other side. And that's x equal to negative 1. Any problems? All right. Let's look at another one. Hold on 1 second. Looking at double fractions. Okay. All right, so we have 7 times x minus 2 equal to 9x minus 6. So first thing we want to do is distribute the 7 so we can have access to this variable right here. All right, so 7 times x will be 7x. 7 times 2 is negative 14. And of course, the right side is not affected. Nothing happened over there. Cannot combine those terms, 9x and 6. Then from there, we have our variables on different sides of the equation. So we have to make a decision on which one we want to move. So we can add 14 to both sides. 14's cancel. And that will leave me with just 7x equal to 9x minus plus 8. It's negative 6 plus 14 plus 8. Now subtract 9x from both sides. And that'll be negative 2x equal to 8. And here, divide both sides by negative 2. X is equal to negative 4. Any questions?
Sorry, sir. Give me just 1 second. I'm still writing.
Yep, not a problem. Let me know when you finish. It's okay.
Okay, thank you, sir.
Not a problem, not a problem. Hopefully y'all didn't hear my baby yelling through. Hold on 1 second. Sorry, guys. Any questions on that? That's 3-3. Any questions before we go to 4-8? 4-8 is just piggybacking off of 3-3. It's just that they add fractions. It will be the same processes, just that they add one more step. And like I said, that involves fractions. All right. Let me see, what do I want to erase? So this is 4-8 here. Yep, just solve equations containing fractions. All right. So if we have x minus 3/4 equal to 1 over 20, and we want to solve for x, so just like in the same fashion, if I had this right here, x minus 3 equal to 1, I would add 3 to both sides. It's going to be the same flow, it's just that we have fractions. So I'm going to add 3/4 to both sides. And so right here in the purple, just re-emphasizing the fraction process. Whenever adding or subtracting fractions, you must have a common denominator. So don't forget that. So far we've added 3/4 to both sides. And 3/4 will cancel on the left, leave me with just x. But then I have to add 1 over 20 and 3 over 4. So I need a common denominator. The LCD, or least common denominator, is going to be the smallest number that each denominator can divide into evenly. So my denominator, or denominators, 20 and 4. And so my LCD would be 20, because of course 20 can divide into itself, but also 4 can divide into 20. So I leave that first fraction of 1 over 20 to be, leave it to be the same. And then you ask yourself what times 4 will give you 20, and that's 5. Multiply 5 to the top and bottom, and that's 15 over 20. Now, once you have common denominators, you can go ahead and add the numerators, and that's how we get 16 over 20, that 1 plus 15. So now if you need a refresher on adding, subtracting fractions, make sure you get with me on it. Got videos of classes that I've done it, or if you just need to sit down and talk about it, then set up that Zoom session. We most definitely can make sure you're good on adding, subtracting, or multiplying, dividing fractions as well. All right, so before we finish off the process, or finish off the problem, any questions on the process up to this point? Make sure we're okay. All right, so now that 16 over 4 can be reduced. You know, that's what I was mentioning before about reducing your fraction. You don't have to convert it to a decimal, but you do need to reduce it as much as possible. 16 is 4 times 4. 20 is 4 times 5. Cancel out those 4s, and you're left with 4/5 as your solution. All right, any problems? Kind of scroll up. All right, so this next one here, we have 3/5 A equal to 9. If I had 3, A equal to 9, I would divide both sides by 3. So it's the same thought process, but don't forget, whenever you're dividing by a fraction, that means you're multiplying by the reciprocal. So what we're going to do here is multiply both sides by the reciprocal of 3/5. And reciprocal just means to flip the fraction. So I'm going to multiply both sides by 5 over 3. All right. Hold on a second. Sorry about that. So multiplying both sides by 5 over 3. And let me cancel out. I'll cancel out. Show you what actually happens here. All right, so 5 over 3 times 3 over 5. 3 over 3 cancels. 5 over 5 cancels, so that'll leave you with just A. Then over here we have 9, which is on the other side of our equation. We have 9 times 5 over 3. Now, if you want, you can just multiply across. 9 times 5 is 45. And then 1 times 3 on bottom is 3. 45 divided by 3 is 15. Or you see that 3 can cancel into the 9. Leave you 3 here, 1 here. Then multiply across. 3 times 5 is 15. 1 times 1 is 1 on bottom, and that'll leave you with just 15. Okay, so I did write the other option right here. See, this is the other way I'm talking about doing it. Just multiplying across. Either way, your answer should be 15. So if you want to cancel out and then multiply, or if you want to multiply, across and then cancel, either way, your result will be 15. The main thing was that you saw that you multiplied by your reciprocal in order to get A by itself. And then you just simplify on the other side of the equation. All right, questions on that? All right, so here we have x over 6 plus 1 equal to 4/3. So you can handle this problem one of two ways. Either you can do this problem the way you see it, in other words, with the fractions involved, or you can do what we call clearing out the fractions. So we'll go through the steps. First thing you want to do is find the LCD between each one of your denominators. So here we have 6 and 3 as denominators. So our LCD, the smallest number that both 6 and 3 can divide into evenly. And we mentioned that back here. So you're talking about the smallest number that each denominator can divide into evenly is going to be 6 for us. Then we're going to multiply each numerator by that 6. So even if your so even if your term does not have a denominator or is not a fraction, you still have to multiply it by the LCD. Everything has to be affected by the LCD, or you will be changing the value of the problem or the equivalency of the equation. So notice we multiply x over 6 by 6, multiply the 1 by 6, and the 4/3 by 6. And also, we also recognize we only multiplied the numerator. We didn't multiply top and bottom, we just multiplied across the equation. From there, you simplify. So the 6's cancel, leave you with 1. 6 times 1 is 6. And then the 2's cancel, or the 3's cancel in the 6 and leave you with just 2. And so the result will be x plus 6 equal to 8. So now notice we have a regular equation with no fractions involved. And we can go ahead and solve like we did in the last section. All right. Then from there, we go ahead and solve the same way we did last section. So subtract 6 from both sides, x is equal to 2.
Can you go up just a little bit? That right there, yeah.
Mm-hmm.
Okay, I got it.
All right. Anybody else before we do another one? All right, so the next one, y over 4 equal to y over 12 plus 2 over 3. Same process. Since we have fractions involved, we want to go ahead and find the LCD so we can clear out our fractions. All right. So LCD is 12. That's the smallest number that both 4, 12, and 3 can divide into evenly. Multiply 12 to each numerator. All right, then simplify. 4 goes into 12, leaves you with 3. 12 goes into 12, leaves you with 1. 3 goes into 12, leaves you with 4. All right, so that leaves us with 3y equal to 1y plus 8, 4 times 2. Any problems? Any problems?
When you have the 4 above the 12 by the 2, how did you get that?
You talking about right here?
Yes.
Yeah, we just did 12 divided by 3. That'll leave you with 4.
Okay.
Yep. Same thing happened over here. Just that 4 went into 12 and left you with 3.
So then you do the 4 times the 2.
Yep.
Okay. Thank you.
Yep. Not a problem. Very good. All right. So subtract y from both sides. That'll leave us with 2y equal to 8. Divide by 2, and y is equal to 4. All right. Any questions before we do another one? All right, so before we go to the next thing, any questions on the process? So the process will always be the same. Find your LCD, take the LCD, multiply it to each numerator, simplify. Once you simplify, you'll go ahead and solve like you did, like you would any of the other equations that we've had up to this point. All right, so here we have 2x, well, not 2x, 2 times x plus 1, and then 2x plus 3 on the other side of the equation. First thing we would do is distribute the 2. And that'll leave us with 2x plus 2 equal to 2x plus 3. So we have x on both sides of our equation. Goal is to get our terms with x one side, our terms without x to the other side. So I'm going to subtract 2x from both sides. And notice that our variables will cancel on both sides. So what I want to make sure that we're clear on in this is you cannot be afraid to let math happen. So, a lot of times what people will do is that they'll cancel out, they'll minus 2x from both sides, cancel out over here, and then over here they'll leave it with x. So they would have had something like 2 equal to x plus 3. So make sure you're careful with that, because if 2x minus 2x cancels on the left, then 2x minus 2x has to cancel on the right as well. So in both cases, the x's cancel out completely. And that leaves you with 2 equal to 3, which is a false statement. Now, our answer isn't false statement. I'm just telling you the outcome that has occurred. 2 is not equal to 3, so that's false. So whenever your variables cancel and you end up having a false statement, your answer is no solution. So that is your answer. The answer is no solution. Any problems? Any problems? All right, let's look at another one that's similar to it. All right, so here we have 4x plus 6 equal to 6 times x plus 1 minus 2x. Distribute the 6. So that's 4x plus 6 equal to 6x plus 6 minus 2x. Combine these like terms on the right side of your equation. 6x minus 2x gives you 4x. Then subtracting 4x from both sides.
When you got 4x, how did you get the 4x?
Talking about over here,
Yes.
I did 6x minus 2x.
Okay.
All right, anything else before we go to the next step? All right, so from there, subtract 4x from both sides, and you're left with 6 equal to 6. So this time we have a true statement. Remember before, variables cancel, and that left us with a false statement. This time our variables cancel, and that leaves us with the true statement. 6 is equal to 6. So if your variables cancel, and you're left with a true statement, your answers are all real numbers. So in the previous one, no values that you plug in for x will work as a solution. In this one, no matter what you plug in, it will work. So everything will work with no matter what number you use. All right, questions? Any questions? Everybody good before I go to the next page? All right. That is 9495. I think we'll do that next class. Okay, so let's do 5, 6 is relatively short, and we'll stop right there. All right. So don't forget that this course is normally 16 weeks, but it is 12 for the summer. So make sure you stay on top of this stuff. So we are expected to cover, more work, the same amount of work, but in a less amount of time. So you are expected to stay on top of this stuff, and it can get a little heavy if you don't stay on top of it. So make sure you stay on top of this stuff. And of course, if you have any questions or need any help, I'm here to do so. So here, solving equations containing decimals. Last section was solving equations containing fractions. If you have a decimal, you treat it the same way you would if it was a regular number. If this was x minus 1 equal to 8, then I would add 1 to both sides of the equation. So here we have x minus 1.5 equal to 8. So I'm going to add 1.5 to both sides of the equation. So now if you were going to do it by hand, you would set it up this way. At least that's how we would back in the day, as old school, adding up decimals. I don't know what's going on nowadays, but you set up your decimal, add a little 0 for your placeholder, and then just add away. And that'll give you 9.5. You guys can use the basic 4-function calculator. So you can, plug that into your calculator, but yeah, they're doing a lot of funky stuff, in high school and elementary now, but that's how we used to do it back in the day. So, yep, so that's how you would do that. Any problems before we go to the next thing? All right, negative 2y is equal to 6.7. You want to solve for that y, you would divide both sides by negative 2. Once again, same process. Same process. And that's y equal to negative 3.35. So the fact that we have decimals doesn't change the process.
So, quick question.
Mm-hmm.
Right side, you do 6.7 divided by -2.
Mm-hmm.
Okay.
Yeah. And so if you were doing it by hand, it would actually be this right here. You would set up the 2 on the outside of your division sign and then put a 6.7 under it and then go from there. But yep, just calculator. 6.7, divided by -2. Yeah. Any problems? All right. So next one, 7x plus 3.2 equal to 4x minus 1.6. So once again, we have an x on both sides of our equation. So your goal should be to get all of your terms with x to one side, all of your terms without x to the other. Subtract 4x from both sides. 4x is canceled on the right side of our equation. On the left side, we have 7x minus 4x, which is 3x. So that's 3x plus 3.2 equal to negative 1.6. Make sure you hold true to the minus signs. Still there. Then we will subtract 3.2 from both sides. Three x's on the left. And then on the right, negative 1.6 minus 3.2 is negative 4.8. All right, then to finish it off, we will divide by 3. And solution is negative 1.6. Any problems? Any problems?
Yeah, quick question. How did you get the 4.8?
Right here, because since we have two numbers that have the same sign, but they're both negative, you're still going to add them together. And so 6 and 2 gave us this 8 right here, and then negative 1, negative 3 gave us that negative 4.
Okay, gotcha.
All right, anything else before we go to the next one? All right, so now, just like before when we had fractions, you can solve your equation with the fractions still involved, or if you want, you can clear out your fractions. So the same thing here, we can solve this equation with the decimal, and some people just choose it because a lot of people don't like fractions, but they don't really have a problem, too much of a problem with decimals because that's money, right? So if you want to leave your fractions in place and just operate, leave your decimals in place and just operate the same way you normally would with the decimals or without the decimals, then feel free to do so. I'm just showing you another way as far as As far as my math, not far as my math lab, but still talking department head. Sorry about that. But as far as your decimals are concerned, so if you want to clear out your decimals, so find the first thing you want to do is find the max number of decimal places. So notice we have one decimal place in the first one decimal place in the second one, but we have two decimal places in that third number. So the max number of decimal places is 2. All right. So then step 2, we're going to multiply each term by a multiple of 10 based on the max number of decimal places. That places could be written better. All right. So since we had 2 decimal places, then we would use 100, one with 2 zeros behind it. If we had 3 decimal places, then we would use 1,000. If it was just 1 decimal place, we would just use 10. So that number of decimal places will dictate how many zeros behind the 1. All right, any problem? All right, so we multiply each number by 100. And then simplify. So they give you 50, 100 times 0.5 is 50. 100 times 2.3 is 230. 100 times 1.65 is 165. Should have put the 4th step down here to solve. All right, so now we can solve it without the decimals, subtracting 230 from both sides. And that'll leave us with 50y equal to negative 65. Divide by 50, y is equal to negative 1.3.
I have a question.
Yep.
So when you put 100 in the ones that only had 1 decimal place over,
Mm-hmm.
still times it by the one who has the most decimal place over?
Yes, because you can't do you can't do something to one thing and not do it to the other things in mathematics, or you're going to change the problem. You're going to change the equivalency of the equation. So whatever you do to one, you have to do to all. So if I were to multiply by just 10, then that wouldn't get rid of this decimal place over here. That would still be 16.5. So I have to multiply by the most in order to get rid of all the decimals.
Okay, thank you.
Mm-hmm. Any questions before we move on? All right. So that's it for that. Questions? Questions? Any questions on anything I've said up to this point? So that's 3 sections. The first 3 sections in your homework. Any questions? Any questions? So we talking to my department head. We can go ahead and stick with Mymathlab. So if you have not opened, let's say if you purchase Connect Math and you have not opened it, you can just return it. But if you have any issues or you have opened it, then I need you to email me specifically so we can see about your situation, see what we can do. See if I need to go through Barnes and Nobles or go through Pearson about seeing about getting money back or whatever the case may be. But so we'll stick with Mymathlab. They are going to change. They have made the decision to change, but that full change is going to occur in the fall. I did the pilot, so I was already in change mode. So I thought that we were just flowing with it because I did the pilot last semester with Mymathlab. So that's why my shell is already set up and everything. So I thought we had already changed, but they said they're going to change it in the fall. So that's where the confusion, came into play. So if you've already purchased it and you have not opened it, you can always return it. And then Mymathlab has something new that I didn't know, my department head didn't know, but you guys found out before me, which is that 12-week purchase option, which is cheaper. And that flows throughout it covers the whole summer. Once again, that does not cover the whole semester. So if you want to go, you have to take another math class. Make sure, you're not signed up for the 16-week math class because that will not help you out. Or you'll come up 4 weeks short. So, but if you do have an 8-week dynamic course or a 10-week course, because I'm teaching some of those next semester, and you pay for just a 12-week session, then you're good to go. Now, I will say this, and I have to check the details because, like I said, me and my department head just found out that they're offering this. If you pay for the full 16-week or the full session, I know for a fact that gives you the option, and we're not thinking about failing the class, but let's say if you were not to pass the class, that gives you the option to take it again without having to pay for it again. I do know that was an option that gives you, 2 chances, to take that course. So I'm assuming with this 12-week option, you're just putting all your chips in, you're going all in and say, I'm going to pass. I don't need to, I don't need a redo as far as this course is concerned. So you are banking on yourself, to be good, good to go coming out the course when you pay for that 12-week option. I will find out the details on the 12-week options, but I'm pretty sure that's another reason why it's cheaper, that you only get this 12 weeks and that's it, and you don't get a redo. But like I said, you guys should be shooting to pass the class, and that's it, because every time you go to a new class, you have to pay for the code again anyway. So it's not like it's going to help you for the next class. All right. Questions, concerns, comments before we close today? Any questions?
Yes. So when you look up the class and it does say Connect Math is the material we need, how do I find the Mymathlab in the bookstore? What is it called exactly?
So now, just making sure we're clear. So you're going to be paying with financial aid?
Yes.
Okay. Let me email me.
Okay.
If anybody have any issues, because if you got these individual issues and stuff like that, email me, because I'm going to email the Mymathlab rep to see what we can do for you guys. Since, like I said, since there was confusion, and we'll go from there. So yes.
Okay.
All right. Anything else? Anybody else? So like I said, let me throw this back at you guys. If you're going to pay with your own money, you should be good to go, because you can just go through Pearson itself and just pay for it. And I think it's a little cheaper anyway to do that, even if they didn't have the 12-week code, 12-week access pass. But if you're going to be paying through financial aid, or if you have any other discrepancies, like one of your classmates already opened the Connect Math, but then went ahead and purchased Mymathlab, let me know, and then we'll go from there as far as seeing what we can do for you. All right. Any questions or concerns before we close?
So I had a dumb, and I scratched off the code already on the McGraw-Hill thing, but I haven't used it. But what I did was I got into Mymathlab and I used the 2-week pass. And what I'm going to do is, after I use the 2-week pass, right before it shuts out, I'm going to pay that $50 for that 12 weeks. So it gives me
Okay.
a little bit of extra time.
Yeah. So now, let me ask you guys this: how much do you pay for the McGraw-Hill? Because I know once you open it and scratch it off or whatever, then you can't return it.
It's
So
like 116, I think, 117, something like
16.
that.
Okay.
Yes, I paid the same.
116. Okay. All right.
And,
So
and with the Pearson, last night I went on, I didn't see the 12 weeks option, so I paid like the full 120.
okay. Okay.
Um,
So we'll see, like I said, email me your situations and let's see about see what we can do. See what we can do.
So is the Math Lab different than the textbook that you bought from Barnes and Noble?
It's a different platform. It's a different platform. And then the setup, how they, give you the problems, the help buttons, and oh, that's one thing I didn't do. I forgot to show you guys before we close out. Let me see where this thing is. Okay, there we go. Forgot to show you guys this. One thing about it, that this had that McGraw-Hill doesn't. Let's get in there. To help me solve this tools. This one have a video. If you want to look at it, it's fine. If not, just click on it and close it out. Then it'll let you get access. All right, so here you have question help. And depending on the complexity of the equation or the problem, you will have different buttons here. Help me solve this will always be here. You click on that if you are, hold on, let me see. You guys made, yep, I forgot you can't see that. All right, here we go. So here we have over here, question help. And this is where I say, help me solve this. You click on this when you're most definitely done with the problem. Like you're just frustrated, you can't figure it out. Because that will walk you through the steps of that problem. And then once you do that, it'll reset it. Most people like to click on view an example, in which it'll open up another window. Problem is very similar, using the same steps, unless you close that out, and then you can go ahead to this one. Textbook, you click on that, it'll send you to where they talk about this type of problem in the textbook. You can shoot me an email or you can print it out. So all of your problems will have these type of help buttons. Let's see.
That's really good.
Yep. That's one of the reasons why I like Mymathlab versus McGraw-Hill. Now McGraw-Hill has a few, but it's not like this. You know what I mean? So, yep. That's why I like using Mymathlab. Let's see.
and
Also, go ahead.
where will you post your recordings?
Um, I do
Canvas?
that. I do that before the end of the week. About the end of the week. Depends on what's going on. Probably on a Friday. I will record them. I mean, not record them. I will make the link through YouTube. Then I will I will email you the link. So I'll email it to you, and then it will be in your Canvas announcements.
Okay, great. Thank you.
Not a problem. So also real quick, when you click the button, show you that's incorrect, try to give you a little hint. Once again, then it gives you about two or three, depends on the complexity of what's going on, 2 or 3 chances to get the problem right. Hit final check, then it'll tell you the answer. So you could click similar questions here or just go to the next one. Let's say if you go to the next one, similar question will always be right here where you can reset the problem and do it over. So very same problem, it's just that the numbers will be different. So it'll be a red X, until you get the problem right. If you were to click here, you'll still see a red X beside that question. Once you get it right, then it will turn to a green check, and then you'll get credit for it as if you never got it wrong. If it's a question that allows partial credit, you will get a green check / red X that lets you know you did it partially correct. Your homework are unlimited. You get unlimited amount of tries to get the best grade possible, and that goes back to this. So before I go switch to the other screen, because I forgot to show you one other thing. Any questions on that? You get unlimited amount of tries to get the best grade possible on your homework. So that's why you want to get the best grade possible, but you want to get at least a 75. At least a 75 on your homeworks. But if you want full credit, you want to shoot for an 85. And I sent that to you in email. I'll show you that in a second just to reiterate that. But any questions on Mymathlab, how it's set up? Because I actually meant to do this when we first talked about Mymathlab, but I forgot to do it. All right. So I sent this to you on Mymathlab specifics. It's an email entitled that. I'm just telling you the details of Mymathlab. I mentioned a lot of them to you already. Letting you know you can't pass without Mymathlab. Your activity will solidify your attendance. Let's see. And then here is what I was talking about, your homework assignments. Looking for at least 75 to 85, 4.9 will give you 90%, but then 85 to 100 is 100%. So you want to score at least an 85. Score at least an 85 to get full 100% for your test, for your homeworks. Now your tests, in this class, they're really kind of unlimited as well. It's just that you don't have unlimited amount of time, You initially have 2 attempts to get your best grade possible. You want to score, I think at least a 75 on your test as well. You get 2 chances to do that. If after the second chance you haven't done that, then you have to get with me to unlock it. And that's just kind of like a barrier to say, hey, okay, you're taking it twice. Let's make sure we're good before we take it the third time, because we don't want to be taking it 4th, 5th, 6th time. Because that's time that you could be using on something else. So if you've already taken it twice, then you don't want to waste time on the third time. Let's do it the third time and knock it out and be done with it. Also, for this class, you have to get a 75 on all of your tests. So it's not an average thing. This class is a pass or fail type of situation. So you do have to get a 75 on all of your tests. So your test reviews are not mandatory, but I will, or I can give you 5 points on your test. If you score 85 or better. I already talked about the 2 attempts. And then also you want to email me a copy of your scratch work for your test, not for your homework. Homework, you don't have to email me a copy of your scratch work, but for your test, you want to email me your scratch work. All right, and that can be done by just taking a picture of it with your phone and sending it to me, or if you want to scan it, whatever way works, that's fine. All right, any questions on that? Like I said, I did email this to you. So you can have, if you didn't write it down right now, you can always reference it in your emails or Canvas announcements. All right. Any questions? Any questions?
So for the homework today, we have the first 3.
Yes. And glad you went there. And that's not saying that you have to have the first 3 assignments done by next class, just letting you know where we are and where you're expected to be as we continue to progress forward. So like I said, you don't have to have them all done, but you do want to go ahead and be getting into that. And even if you don't have Mymathlab access yet, the full access, you do want to go ahead and jump on that 14-day free pass so you can get in there. All right. Anybody else?
Yes, I do have a question.
Mhm.
So I'm reading the email that you sent that says on the same page that we're on, but the second from last bullet. So we got 2 attempts without proctoring, or is all of it with proctoring?
Oh, you know what? That was not supposed to be there for you guys. That's for another class. But see, so I mean, that's okay. The statement, I guess, is okay because it says for the test that you can attempt without proctoring. But that's for another class. I don't have the luxury of giving you guys tests without proctoring because of the dynamic of the developmental course. So all of your tests will be proctored. So, and all I was saying for that statement is that I have classes wherein I give them unproctored tests, and then classes where I do proctor the tests. And so for the ones that they have unproctored, they get 2 shots. But you guys, all of your tests, you know, you can take them as many times as you want. It's just that all of them has to be proctored.
Okay, thank you.
Yep, not a problem. Thank you for pointing that out. All right, anybody else before we close? All right. So, you guys have a good one. Be safe. I'll see you on Wednesday, and let's have a great summer session.
Thank you.
All right,
Thank you,
thank
sir.
you. Not a problem. Have a good one.
Have a nice one.
Thanks. You do the same.
Thank you. See you Wednesday.
Take care. Thanks.